Hello, today we'll discuss about analog communication system. Before that, first we'll discuss about or we'll see about introduction to communication system. Basically, a communication system involves the transfer of information or intelligence from one place to another. Ideally, it is called as source to destination. So the blocks involved in a communication system are source, transmitter, channel through which the information flows, receiver, and the recipient. Next, the modulation techniques. In modulation techniques, we have different types of modulation techniques like AM, FM, PM, and pulse modulation. So first we'll see what is an amplitude modulation. In amplitude modulation, the amplitude of message signal is changed in accordance with amplitude of carrier signal, with remaining factors constant like frequency, phase, etc. Then amplitude modulation, it can be defined in time domain as well as in frequency domain. So a carrier signal is needed to change the carrier signal's amplitude is changed in accordance with the amplitude of message signal. So this is ideal graphs, or we can say it has plots of amplitude modulation. Here we'll see EC, it is a high frequency carrier wave whose frequency is very high when compared with the frequency of message signal. Here the message signal is indicated as EM, where small e represents the instantaneous change and capital E represents the amplitude of the signal, and we see the resultant of these two waves. In this we see an imaginary wave form is formed on the envelopes of this carrier signal. Then for amplitude modulation in frequency domain, it is so in order to calculate the spectrum and in order to define the sidebands of the amplitude modulation, we need to define this amplitude modulation in frequency domain description. So in order to have a frequency domain description, we should apply Fourier transform. Then this represents the frequency spectrum of AM modulation, in which we see two frequency bands. They are placed at equal distance from the carrier frequency FC. So here the carrier frequency FC is in middle of LSB and USB. LSB consists of the difference of the frequencies of carrier as well as message signal, and USB consists of the addition of the carrier signal as well as message signal. Then comes the power relations. We can see there are many different relations between current, power as well as voltages in AM waves. So here the power relationship is given as PD equals to PC into 1 plus m squared by 2. And this shows the current, and this shows the modulation index. Modulation index is one of the most important concept in modulation, which shows the degree up to which the signal can be modulated without any distortion. So here EM by EC represents the maximum modulation it can produce. If the amplitudes of EM and EC are same, then the modulation index M will equals to 1, which shows the 100% modulation. So equally it can be calculated on oscilloscope experimentally by using the empirical relationship Emax minus Emin by Emax plus Emin. So here we have three different types of modulations, or percentage of modulation or modulation index. When EM exceeds EC, then it is called as over modulation, in which the information is lost. If both are equal, then it will be 100% modulation. If EM is less than EC by half of it, then it is called as under modulation. Then this shows the different effects of over modulation and perfectly modulation. If there are many message signals which are to be transmitted using the same carrier signal, then the empirical formula what we have is mt equals to under root of m1 square plus m2 square plus and so on up to mn whole square, where m represents the modulation index of each what we say signal or message signal. And this shows the current power and current relationships for complex waveform. Complex waveform we mean by wherein different or many message signals are transmitted.